these ones want us to rewrite them all in terms of sine of theta. Last time we did cosine theta. Cosine squared theta. Look where you see cosine squared somewhere. When you have this squared stuff, it typically comes in the Pythagorean identities. So cosine squared theta, if you had to get rid of the sine squared theta, you would subtract it to the other side. So it would be 1 minus sine squared theta. Now again, you can't cancel these out because they're not exactly the same, but you can do the difference of squares thing. You could square root 1, you could square root sine squared. Square root of 1 is 1. Square root of sine squared would be just sine. 1 plus sine of theta times 1 minus the sine of theta. All of that is over 1 minus the sine of theta. And now you'll notice you can cancel out the 1 minus sine of theta because you have an entire product there. So we're left with 1 plus sine of theta. You can't simplify any more off of that. So let's try this one. Let me get my chart. Oh boy, too far. Cotangent squared, we want it in terms of sine or cosine in this one? Sine. Okay, so cotangent, if you look at cotangent, the typical cotangent is just cosine over sine. So we can just say cotangent squared would just be the cosine squared over the sine squared. But again, we want it to be all sine stuff. We can't have that cosine squared stuff. So we can go to an identity where we have cosine squared, just like we did. So if I wanted it to be sine squared, cosine squared would be equivalent to 1 minus the sine squared. Now again, we can't even cancel these out because it's not a full product, but we can split the fraction again. So we can make this 1 over sine squared theta minus sine squared theta over sine squared theta. Now, sine squared theta over the sine squared theta, that would simplify to just 1. But you can't do anything with 1 over sine squared theta. So this would be our final answer on this. This is all we can do. We've simplified it as much as possible. Yeah! Yeah!